Good morning, I'm Stefania Varano, and I will present to you today a recognition of the use of visualization in non-visible science and the study of possible alternative sensory representation. This study is made in collaboration with Anita Zanella. We both are from the Italian National Institute for Astrophysics. Scientific visualization is any visual representation of data in the form of images and diagrams that is used by scientists and science communicators to better understand themselves and also illustrate their research results and discoveries. This is an example, which is a release from NASA in July 2015 about the discovery of a planet which was very similar with the Earth. Images are codified in the sense that they are the result of a set of rules that encode information in a visual form. This code is often tacit, and this can lead to misinterpretation, misunderstanding, and so on. And this is the case of the image that I showed to you before, that was not always accompanied by its caption that stated clearly that the image was an artist's concept and not a real picture of the planet. Data in science can be abstract or concrete in the sense that they can be the result of a calculation or the application of a model or the result of a direct observation. And the representation of this data can be figurative in the sense that they recall the morphology of the observed objects, or arbitrary in the sense that they are more symbolic, such as plots or diagrams. Objects in science are invisible because they do not emit light, or because they are too small to interact with light, or because they are not accessible to scientific instruments. And in all these cases, we use different type of visualization and representation to show the data that we have collected in indirect ways. So if the data are not visible and the things are not visible, why do we use images? We could use whatever sensory stimulus to represent the presence of a signal that overcomes the background noise. And this is the case of tactile representation or acoustic representation. And all of them imply the use of more abstract features in the display because they are not realistic images of the objects. They do not recall the real aspect of the object. So we consider that we argue that going non-figurative has a lot of advantages, such as the fact that we can use more representative parameters if we also use multisensory representation, and then we can include more data. And also using synesthetic representations allows us to be more accessible, to create more accessible activities for also sensorial disabilities. And in the end, we doing abstract representation, and we can produce more challenging and effective activities and displays for the public. Our display is not very effective in an aesthetic sense because it's a wooden board with some columns of bolts, of metal bolts that sound when touched. And each of the features of this display is representing a scientific aspect and feature of the represented objects. The code here is that the spatial position on the board, of the objects on the board, represents the position in the region of the sky that it's represented in 2D. The physical heights of the column of bolts represents different intensity of the signals, and different frequencies of the sound represent different distances from the observer. The experimentation was led in 3 parts with only tactile, only acoustic, and then both tactile and acoustic representation. And all 3 of them were submitted to users that were both sighted and blind or visually impaired. The results of our experimentation show that in any case, whatever are the stimuli of the display, the users do analogies, make analogies with their personal experiences and memories. Therefore, we need to have a careful and conscious design of our displays and our activities. Then the fact that in this very abstract representation, choosing what is relevant to study more in detail, it's very tough. And this reflects a lot the real nature of science, in which we don't know what to look for, and we have to decide while studying what is worthy more a deeper attention from us. And in the end, there was a very, in the beginning, a very low emotional engagement, no wow effect, let's say. And this also was an advantage because allowed easier identification and reception of the presence of a code, showing that the image and the representation was not realistic at all. With regards to the acoustic representation in particular, we have seen how figurativeness is possible also with acoustic stimuli, because we always try to find a connection with our experience and memories. For example, the Doppler effect that was connected to the sound, since it was related to the distance of the objects, but it was not indeed in the design of the display. And the fact that the universe is not necessarily neat and harmonic, and sound tend to be. So in the case of, and also in the case of our representation, by chance we had the results that if touched in a certain sequence, the objects of the display made a C scale. And this was also an opportunity to talk about the causality in science and the real nature of astronomical observation, which are very chaotic indeed. About the future, we are planning to design an activity that will allow users to make their own representation of the universe using haptic or acoustic or even visual stimuli. And also we are creating this individual haptic and acoustic planetarium because we have seen how blind and visually impaired users have many difficulties in recognizing perspective, and they have to have a closer analogy with the position of the objects in the sky as we see them. This is all. These are our contacts. Any comment or ideas, or willing only to talk to us about this work and collaborate with us, it's very, very welcome. And so thank you, and see you next time. Bye.